There was no darkness. There was no light. There was no space stretching endlessly in all directions, and no time flowing from past to future. There was no before. Because before the universe, there was no such thing as before. The laws of physics had not yet been written. The constants that govern matter and energy did not yet have values. There were no atoms waiting patiently to form, no stars suspended in distant silence, no galaxies rotating in the dark. And yet, 13.8 billion years ago, though even that phrase assumes time, something happened. Not inside space, but the event that created space. Not in time, but the event that created time. We call it the Big Bang. The name suggests an explosion. But it was not an explosion in space. It was the expansion of space itself. There was no center, no edge, no outside into which it expanded. The entire observable universe, all matter, all energy, all potential structure, was compressed into a state of extraordinary density and temperature. Then, in less than a trillionth of a second, reality unfolded. Space-time expanded faster than light. Quantum fluctuations, tiny irregularities at microscopic scales, were stretched to cosmic proportions. Those fluctuations would one day become galaxies. In those earliest moments, the four fundamental forces of nature were unified: gravity, electromagnetism, and the strong and weak nuclear forces were aspects of a single force. Physics, as we know it, breaks down at this boundary. Our equations blur, our theories reach their limits. But what we can say is this: the universe began expanding and cooling. As it cooled, particles formed, quarks and electrons emerging from pure energy. Quarks combined into protons and neutrons. Matter and antimatter annihilated one another in flashes of radiation. For every billion pairs that destroyed each other, one particle of matter survived. That tiny asymmetry, that slight imbalance, is why you exist. Had matter and antimatter been perfectly symmetrical, the universe would contain nothing but light. But because of that imbalance, structure was possible. Within 3 minutes, the first atomic nuclei formed: hydrogen, helium, a trace of lithium. The universe was still too hot for electrons to bind to nuclei. It was a glowing plasma, opaque and radiant. For nearly 380,000 years, light could not travel freely. Then, as expansion continued, temperatures dropped enough for electrons to combine with nuclei. Atoms formed, and suddenly, photons were free to move. Light traveled across space for the first time. That ancient light still exists today. We detect it as the cosmic microwave background, a faint whisper from the universe's infancy. After that first light faded, the universe entered a long darkness. There were no stars yet, no galaxies, only vast clouds of hydrogen and helium gas, expanding and cooling. But the tiny density fluctuations imprinted during inflation were still there. Where matter was slightly denser, gravity pulled more matter inward. Where matter was slightly thinner, space expanded more freely. And there was something else, something invisible: dark matter. We do not know what it is made of. It does not emit light, absorb light, or reflect light, and yet it outweighs ordinary matter by a factor of 5. Dark matter formed the invisible scaffolding of the cosmos. Gas fell into its gravitational wells, clouds collapsed, and after nearly 100 million years, the first stars ignited. They were unlike stars today. They were enormous, hundreds of times the mass of our sun. They burned fiercely and died young. Inside their cores, hydrogen fused into helium, helium fused into carbon, carbon into oxygen, oxygen into heavier elements. When these massive stars exhausted their fuel, they exploded as supernova. In those explosions, the elements necessary for planets and life were forged. The calcium in your bones, the iron in your blood, the carbon that forms your cells, all created in the hearts of dying stars. We are made of stellar debris. We are, quite literally, star stuff. As generations of stars lived and died, galaxies formed. Spiral arms unfurled like cosmic whirlpools. Elliptical galaxies merged in gravitational dances lasting billions of years. At the centers of nearly every galaxy, supermassive black holes emerged, millions or billions of times the mass of the Sun. Gravity-sculpted structure on scales beyond comprehension. And within one modest spiral galaxy, in one unremarkable arm, a molecular cloud collapsed 4.6 billion years ago. Our Sun was born. Around it, a disk of gas and dust rotated. Dust grains collided. Pebbles formed rocks. Rocks formed planetesimals. Planetesimals collided violently, merging into planets. The early solar system was chaotic. Worlds collided. Surfaces melted. A Mars-sized body struck the early Earth. Debris from that impact formed the Moon. The Moon stabilized Earth's tilt, generated tides, influenced climate. Early Earth was molten and violent. Asteroids bombarded its surface. Volcanoes filled its atmosphere with gases. Then water accumulated. Oceans formed. And in those oceans, chemistry began to organize. Atoms formed molecules. Molecules formed chains. Chains formed structures capable of replication. Life emerged, not complex, not conscious, but alive. For billions of years, life remained microscopic. Then photosynthesis evolved. Oxygen accumulated. Complex cells formed. Multicellular organisms appeared. Life diversified in an explosion of forms. Eyes evolved. Nervous systems formed. Predators and prey entered an ancient dance. Mass extinctions reshaped the trajectory of life. Asteroids struck. Climate shifted. Species vanished. But life endured. On one small branch of the evolutionary tree, a species developed language, symbolic thought, the ability to imagine the future, the capacity to ask why. The universe had produced a structure capable of reflecting upon itself. We are the universe becoming aware of itself. When we look at the night sky, we are looking into deep time. The atoms in our bodies were forged billions of years ago in stellar furnaces. Those stars were born from fluctuations stretched during cosmic inflation. We are continuous with the cosmos, not separate observers, participants. In 1998, astronomers discovered that the expansion of the universe is accelerating. Something, dark energy, is pushing galaxies apart. Roughly 68% of the universe is dark energy. 27% is dark matter. Only 5% is ordinary matter. Everything we have ever known belongs to that 5%. In the far future, galaxies will drift beyond our observable horizon. Stars will exhaust their fuel. Red dwarfs will glow faintly for trillions of years before fading. White dwarfs will cool into darkness. Neutron stars will grow cold. Black holes will dominate. Even black holes may eventually evaporate through Hawking radiation. The universe trends toward thermodynamic equilibrium, maximum entropy, a thin whisper of radiation in an ever-expanding void. But this is extrapolation. Physics has surprised us before. What came before the Big Bang? Was it the absolute beginning, or one phase in a larger cycle? Could our universe be one bubble among countless others in a multiverse? Are there dimensions beyond those we perceive? We do not know. And that is not a failure. It is an invitation. For most of human history, we believed we were central. We learned we are not central in space, but we may be extraordinary in capacity. On one small planet, For a brief flicker of time, the universe has begun asking questions about itself. The same physical laws that govern supernovae govern neurons. The same particles forged in stars compose our thoughts. When you contemplate the cosmos contemplates itself through you. Perhaps one day we will understand more. Perhaps the deepest truths lie beyond the horizon of human cognition. The story of the universe is still unfolding, and we are part of that unfolding, temporary, curious, alive, in a cosmos vast beyond comprehension, and yet intimate enough to produce us. The questions remain open, and in that openness, science lives, not in certainty, but in wonder.